Question: is scientific notation different than everything else we've been doing? Yes or no?
Sure. No.
Okay.
Not really.
Okay. What is scientific notation? Give me a form. Somebody give me some on the board. 3,000. That's the number. 3 times 10 to the third. 3,000. Okay. What operations are on the board? Multiplication and exponent. Everybody, listen. And I don't like using the x, so I'll do this. Isn't this just what we're told to do? All right, let's be clear. Scientific notation is not special. It is simply, listen, it is simply exponent and multiplication. That is the first thing we have to realize. All too often you guys have been trained to think it's different. And you think, if I move left, I do this. If I move right, I do this. Well, listen, if you're memorizing rules, you're going to screw it up. Okay? That's what happens. What you have to realize if I wrote x squared x4, what would it be?
X6.
What do you think 10 squared 10 4 has to be then? 10 6. It is simply exponent rules, guys. What about the times 3? Well, we just leave that hanging out. This is what? So how many zeros, what number is this in 3 followed by 6 zeros? What number is it? 3 million. All right, 3 million. We should be able to. 3 million, 6 zeros, right? 3 times 10, 6 zeros. All right. But
1,000 million again.
all right. When you have, listen up, when you have whole numbers, it's pretty easy. You have to see how many 10s you can factor out. Now, you can skip this step, but until you are really good at this, I think this is worth our time. You guys agree it's that?
Yep.
Is that the same number?
Yep.
Now, but what does 10 times 10 times 10 times 10 become?
10 to the 4.
10 to the 4. All right.
You know what?
Now that's easy when there's a lead number and all zeros.
Yeah.
All right, so what about,
10 4 zeros.
all right, now scientific notation, the only thing special about it is that the lead number is a number that's greater than or equal to 1, but less than 10. It can be 9.99999, but we always have the lead number be between 1 and 10. It's a single unit, it has a units digit, and that's it. Everything else is a decimal. So if I look at this and I say, hey, first of all, do we see there's 3 10s here?
Yeah.
So are we getting good enough to see that as 3? Can't I write this as 102 times 10 to the third?
Yes.
But now I got to make this into a.
Lead number that's less than 5.
So the way I always think of this is I want this to be 1.02. How many decimals do I have?
1.02.
Yeah, it's going to be times 5 because listen, to make 102 into 1.02, what do you got to divide by? 100. But if I divide the bottom, I have to multiply. Well, there's no other side, is there?
Sorry. If the add to 0.
You got to multiply by 2 zeros. We don't add to the top and bottom fractions, right? 1/2. If you add 1 to the numerator and denominator of 1/2, you get 2/3. 2/3 and 1/2 aren't the same. We always multiply. I know it seems like, so it's 10 to the 5th. Now, what you guys do typically when you learn this, you go 1, 2, 3, 4, 5, boom. But here's the problem. You guys forget whether this is positive or negative because you think you shouldn't even fathom that 1.02 times 10 to the negative 5 could be this. Because how do I make this exponent positive? Put it to the bottom. So if I take 1.02 divided by 5/10, could that possibly be a big number?
No.
Negative exponents have to be positive. Now we'd like to do that. We should see that. The ones we struggle with more than that are these.
I don't like ones in front of me.
How do I convert? And now, not what the answer is, because someone here has probably memorized the rule. I'll tell you right now at the bottom, we got to get 2 times 10 to the negative third. I'll tell you the answer, 'cause that's immaterial to me. How do we convert 0.002 into the whole number 2? Almost. What do you think? All right, guys, I think I have to multiply this by 3 zeros to get 2. But I'm not allowed to just do that. If I'm going to multiply the top, I have to multiply the bottom. What's on the bottom? Do we agree 1? So 1 times 1,000. You guys agree 1,000 times 0.002 is 2 over 1,000. But didn't we agree that 2, that's 10 times 10 times 10? 1,000? And this is 2 over 10 to the third. But when you move, how many terms is this right now? 1 term. So we can move it. Okay? 1 term. So when we move 10 to the third from the bottom to the top, now, do we need to do all these steps? Well, the answer is for your homework you're going to have to. You're going to write me a worksheet that explains what this just did. So I'd like you to write me a worksheet.
We're writing a worksheet.
Yeah! Like an instruction sheet, I call it. Not a worksheet. The worksheet is a problem. I want instruction sheets on how to convert, but I don't want just...
Will you give us the problems?
No. So listen, here's the rule. I do not want to hear any of this in the instruction sheet. When you go to the right, it is positive. When you go to the left, it is negative. Our rule is that we work from inequalities. I just want you to be able to show... Think about it. I think you need an instruction rule for converting a number like 102,000. And I think you have to have a rule that converts something like, and I would not use 0.02, maybe like 0.00037. Right? And the only rule you have to know is that that has to convert this way. That's why I made the video, so you can watch this again. And you know, based on scientific notation, that the lead number in the multiplication thing you're creating has to be between 1 and 10. You need to not witness scientific notation, anything different than exponents and multiplication. That helps. Oh, because it's easier to handle that way. And when we deal with like moles and stuff, well, a mole is 6.02, right?
Yeah.
A mole of atoms. When you deal with a mole, this is usually the number that gives us magnitude. All right, but the lead number a lot of times is important. Listen, I'll use the government's debt, 1.4 times 10 to the 9. Does it really matter? You know, I don't really care after the 0.4 what's happened. So a lot of times we look at it that way.
What's after, like, trillion?
Oh, quadrillion, I found out. So the bracket, I don't know. I think it's quintillion. I think so, but I'm not sure. All right.